let's divide by an 11th root. Now I choose an 11th root just to exaggerate here. We're not allowed to have a radical in the denominator. However, I can't multiply by the 11th root of this denominator over itself. What I need to do is I need to have 11th powers inside. So I've got to get creative on what I multiply numerator and denominator by. Both of these will be 11th roots, and I've got an a squared. I need to multiply by an a to the 9th. That will give me an a to the 11th. I've got b to the 7th. I need to get that 7 up to an 11, so I'm going to multiply by b to the 4th under there, and I need 3 more c's to complete an 11 of a kind, so c to the 3rd over c to the 3rd. Now let's look at what we have. In the numerator we have the 11th root of a to the 9th, b to the 4th, c to the 3rd. But in the denominator we have created 11th powers. We have a to the 11th, b to the 11th, c to the 11th. And we've done that by design specifically so we can have a, b, c down in our denominator. Our numerator will remain the 11th root of a to the 9th, b to the 4th, c to the 3rd. So what have we done here? We have found something creative to multiply by, and I like to say that we multiply by that which creates an n of a kind. Now in this problem we were creating an 11th of a kind because we had an 11th root, and so I was looking at what I could add to these internal exponents to bring them up to this 11 level. So you're creating an n of a kind where n is the index in the problem. For problem 9, instead of thinking of that 9 inside the radicals in 9, let's think of it as a 3 squared. Get down to its prime factors. Now when we multiply by something, we're going to have to create cube roots, create 3 of a kinds. I've already got 2 3's. I need 1 additional 3 to create a 3 of a kind. I've got 2 b's, so I need 1 additional b to create a 3 of a kind. Now when I look at what I've got the cube root of 27, which is 3, the cube root of b cubed, which is b down in the denominator. We've rationalized the denominator. There's no irrational numbers down there. Our numerator is going to be the cube root of 3b, and no cancellation is possible. For number 10, I need to create 3 of a kinds inside that radical. So I'm going to multiply by the cube root of 7 times 7. I need 2 more 7's to create a 3 of a kind. That will give me the cube root of 7 times 7 times 7, which is going to come out as a whole number 7. And then I've got a 2 on the outside up in the numerator times the cube root of 49. And don't cancel the 49 and the 7, because remember the 49 is trapped inside the radical. On number 11, before I start to rationalize, I'm going to simplify what I've got here. I've got a couple of choices. The 81 is a 4th root. So I can either, let's take this 2 different ways. I can either take the 4th root of 81 and have 3 over the 4th root of 6. That's one option. Or if you note that 81 and 6 both can be divided by 3, I can rewrite this as the 4th root of 27 over 2. 2 totally different ways to approach this problem. Now, let's take each one of these separately. The first way, I just need to clean up the denominator. I need to multiply by the 4th root of, and I need 3 more 6's inside that radical so that I can have a 4 of a kind. If I do that, I'm now going to have 3 times the 4th root of 216 over 6, but the 3 and the 6 can reduce with each other, and that will just give me 1 over 2, so leave a 2 in the denominator and have the 4th root of 216 in the numerator. If we look at this second way of approaching the problem, we need to multiply by the cube root of 2 times 2 times 2, in order to get 4 of a kind with our 2's down in the denominator. That will take me straight to a 2 down in the denominator, and 27 times 2 times 2 times 2 is going to give me 216 inside the radical. So even though it's tempting to take that 4th root of 81 right at the beginning, if we ask whether we can reduce the radical inside first, notice that the work is a little bit quicker and easier to do. In this next problem, we have a 4th root divided by a 6th root, and we know that we have to switch into rational exponents to be able to do this. So what we have is a to the 2/4 b to the 3/4 divided by a to the 1/6 b to the 2/6. Now, since I've got 4th roots and 6th roots, I'd rather have a common denominator of 12 to work with. So let's rewrite this as a to the 6/12 b to the 9/12 divided by a to the 2/12 b to the 4/12. Okay, now with each of these expressions, I can subtract exponents. 6 minus 2 is 4, so I can have a to the 4/12 and b to the 5/12. Since this began with a radical, it should finish with a radical, and so we're going to have the 12th root of a to the 4th b to the 5th.